5G is going to change our lives completely. This shift is going to be once in a decade upgrade of a wireless system. And that's because 5G networks are designed in order to address highly complex services and applications, such as the support of millions and billions of interconnected devices, what's known as massive machine communication. The only problem is that only 25% of the Earth's landmass today is covered by cell towers. The rest of the land, the oceans, have no coverage. We cannot use traditional legacy satellites in order to address this problem because they are too expensive and far away from Earth, introducing delays and latencies. For truly global 5G massive machine communication to be enabled, a truly low latency of only a few milliseconds is a must. And at OQ Technology, we try to address this problem by enabling 5G massive machine communication all over the world, from North Pole to South Pole, using a constellation of nanosatellites, and by pushing down the latency into fiber-like speed using low Earth orbits, which are hundreds of kilometers away only.
At OQ Technology, we think that the interconnected and intelligent world implied worldwide connection and sensing. We want to monitor assets in remote areas. For that, our solution will be low cost and enable low power consumption devices. It will also have modern features such as state-of-the-art security. The system will also be scalable and, in the full deployment phase, enable low latency access to the global network in a seamless manner.
Today, to send 1 megabyte of data from remote and rural areas, it can cost sometimes 2,000 times more than in cities and urban areas. And this is because of the large cost of the infrastructure of large satellites, giant antennas and bulky user terminals. We want to change this. So a user, if he or she uses a cellular IoT device inside a city, they can still use this anywhere in the world seamlessly using our satellite network with a simple software upgrade. So this means for consumer and industrial customers, they don't need to deploy two types of networks, terrestrial and satellite, but only one wireless solution, which in the end reduces their cost of ownership and operations immensely. Industry 4.0, like the energy sector, for example, oil and gas, upstream and midstream applications, maritime applications, predictive maintenance, SCADA applications, smart metering, mining, but also especially with respect to transport and logistics with fleet management and tracking of critical assets.
There are exciting new challenges. The main challenge is the scalability of the system, both in terms of deployment and performance. We are working on a software-defined radio type of system in a first phase where we'll be able to upgrade a satellite on the fly the same way you would upgrade your phone or your computer. In the deployment phase, we'll have our own dedicated payload. There are also specific challenges due to the non-terrestrial nature of the communication systems. For this, we are built upon the most advanced and non-proprietary technologies developed within the 3GPP consortium. For example, it could be 4G LTE or 5G. There are also communication problems such as the challenges of synchronizing and decoding the signal sent from a rapidly moving satellite. For that, we specifically tailored algorithms that can track and successfully communicate with LEO satellites.
We are supported by the Luxembourg Space Agency since 2017 under the National Space Program Lux Impulse. So we started with a feasibility study to discover the market, find the right technology that fits this market, and to figure out how we make 5G works over low Earth orbit satellites. And that concluded successfully, and then we moved into the phase of developing and testing the technology in orbit, like with the Tiger mission and the upcoming MaxSat mission.
The Tiger mission is an experimental success. It has permitted us to go beyond system simulation and validate in practice via experiment that 5G IoT could be successfully used in conjunction with software-defined radio and specifically tailored algorithms. It is a first step toward our global mission, which is to connect everywhere, everything with low latency, low cost and low power consumption devices.
Yes. Our future vision is to make every cellular device speak the same language as satellites and to help mobile operators extend their 5G massive communication beyond cities into rural and remote areas globally through space.